6. All right, that's it. All right. Something happened, but I'm not sure what. Okay, well, whatever it is, it's not happening twice. So let's focus on this. Intersections. Given two singly, well, let's create the new one first. Chapter 2, problem 7. Intersections. Oh, I can guess what this is about, and I don't like it. Alright, did I read this? Anyway. Let's kind of move this over. You know what I should do tomorrow is actually just use enter to run the test automatically. Anyway, that's fine. Okay, that's just super confusing. Alright. Intersection on a list. On two lists, right? LS1 and LS2. And well, this one's kind of hard to write, or it's a little bit hard to write test for. I guess it should return the list that it intersects at or nil, right? So what is an intersection really? So first of all, given two singly linked, all right, what is the problem description? Given two singly linked lists, determine if the two lists intersect. Okay, so first of all, we do have to answer that question. Return the intersecting node. Note that the intersection is defined based on reference, not value. That is, if the kth node of the linked list is the exact same node by reference as the jth node of the second linked list, then they are intersecting. Okay, cool. I'm going to ignore the Alright, so I think one thing we can actually do here is sort of make our R statements a little bit easier to process and reason about. Do we want to do this? Now let's just make them list 1 and list 2. I changed my mind. So pretty much like every other problem has been. If we need to, we'll reconsider this. And so what does it take? I guess obviously it takes two lists, right? So at least two lists. Alright, the first test should just be this. In this case, neither of these two things intersect. Yeah, you know what? Let's do it. Let's be a little bit more clever about how we do all this. Okay, so let's actually do 2. Well, if I do this, then every list has to intersect, doesn't it? There's no good way to use R on this, I think. No, there is. Okay, yeah. So shared. Okay, let's just do this. I don't know why I'm doing. Okay, so LS1, let's say 1, 2, and then 3, 4, and they share 5, 6, right? And so what should happen is you should say that the part they shared is the list 5, 6. What we need to do is intersection. Okay, so it's going to take 3 things. It's going to take I guess it's going to take a shared list 1 and a list 2. so already let's fix that up. Might as well call it just the whole thing. What do we say here? List 1, list 2. Okay. List 1, list 2. Draw a little music for myself. Okay. So, given that, 1, 2, 3, 4, 5, 6, right? So, I'm gonna reverse what I said. You know, no, I actually still like it this way. It just makes it easier to. All right, so all right. So that's how we're going to do it. All right, so when I say this, what I really mean is I want you to build me a list that is going to be list 1, L1, which is going to be the concat of list 1 and common list. All right, and list 2 is going to be the concat of list 2 and common list. All right, and yeah, that's about it really. And so that's actually what list 1 and list 2 actually is. And so then we're just going to call intersection on list 1 and list 2. Okay, that seems reasonable. And so we're saying for 1, 2, 3, 4, 5, 6, what are we effectively saying? Well, we're saying 5, 6 should be the intersection, right? And actually, you know what? I kind of agree. We need to rebuild this out of this too. I am not sure if this is going to work. Let's see. I kind of don't think it will, but let's see. Huh, this is actually kind of weird. Maybe I'm making this way too complicated. Yeah, this is just too much. I mean, let's back up. Rather than doing this, let's just do test is. And, geez. Okay, so what we need to do, t/testing. I guess we don't really need to make a test for each of them, but let's start with just this simple case, which is you should have no intersection, or a nil intersection, I guess, in the event that there is no actual intersection between the two of you. 1, 2, 3, and 4. Well, let's do 1, 2, 3. Yeah. Yeah. And what is this testing actually? Well, this is actually testing that intersect is based on ref, not value, right? That's a better way of putting that. On reference, yeah, okay. I forget exactly how they print out when you do this. So this is basically testing that it is based on reference, right, not value. And I say that because like these are the same, right? So they should, if you were intersecting based on value, they would be the same, right? But it's by reference. Okay. Technically, these are vectors, not a list. I mean, we can make them into a list if people care. It doesn't make any difference. In this case, I mean to say. Okay. What else can we test? That intersection is based on reference. That we return nil. That we get nil if no intersection. I guess, I mean, that's kind of the first one, I guess, that we get nil if there is no intersection. Why is there no intersection? Well, in this case, it really is because they're actually different. So let's just say 1 and 2, right? These are clearly different lists. They actually have no shared base, and so it should return nil. This one has identical values, right? But, and so there is no intersection. This one, so what if we do this though? VS or LS, right? If we do this, right? Now, there's no need for that. Not based on that. The base is based on reference, right? So if we do this and then we say LS, LS, right? So now we're saying, are these two guys the same? And it's not necessary. We could say this as the result, but it's also the case that LS. Actually, wait, no, it is. It is the case that it would need to be some subset of this. In fact, I feel like I'm gonna use the list anyway, even though they're kind of weird. Nobody does this, you know, and that's actually kind of weird too. I feel like maybe. Yeah, maybe I like the other one kind of better. All things being equal. Alright, so we're defining two lists. Alright, so these definitely have no intersection. This one has their different lists, basically. So this is why I was like trying to build that thing up, because there's just so much to kind of set up for each test. It's kind of felt like that would be the right thing to do, but I think that then it's like more code is going to go into the testing than even the thing. Alright, so this is list 1, 2, 3. And, okay. So this one should intersect, right? Should be the case that actually the whole thing intersects, right? What else? So, and now let's try some smaller cases. So something similar to this. I guess we don't really need every one of them to be test intersections, which is kind of duh, but if it's kind of duh, then don't do it. All right. All right. 1, 2, 3 is our original list, but we can pass in LS and the rest of LS, right? So one of them is going to be 2, 3, and one of them is going to be 1, 2, 3, right? And it should return the rest of LS, and those should be equal. Now, strictly speaking, this is equality equal, right? Not identical equal. I don't actually know I think they're also identical equal. That's a good question. That is a good question. I don't know if rest always returns the same sequence. Yeah, that's something I've never thought about. That's interesting. Okay. Well, let's see what happens, you know? Is it going to be... I mean, in this case, it will be, right? LS is just, it's all the same thing. But in this case, can you put... can you only do identical, or can you also do... Or sorry, can you only do equal, or can you also do identical? I mean, I should be able to, to say shared is the rest of LS, right? Or sublist, I guess, right? Let's say the rest of LS, right? And now, like, this should work, right? Let's just do the things that work, and I'll try the the weird one that I'm not really sure about, honestly. And we're gonna do one that's pretty much identical to that, except gonna reverse the order. Okay. And what else do we need? Yeah. The thing that makes this whole thing messy is this whole by reference rather than by value. It's weird. But okay. Let's try one final one. It's a common list, which is going to be 4, 5, 6, right? Which goes through 7, 8, 9. Just to make it simple. And so that's the common. That's what we should actually return. We should actually return, right? But then the L1 is going to be the concat yep, yeah. But the L1 is going to be the concat of damn, is this going to work by reference? I'm just not sure. I don't know if I do a concat on, for instance, 1, 2, 3, and then common, whether I actually do have a common, or whether this is another sequence over this sequence, and so it's not going to be reference equality. I'm just not clear about this with closure list. Anyway, let's see what happens. So L2 concat 4, 5, 6 common. I mean, I feel like at least I mean, this is a terrible way of writing it, but I could say cons 4 and then like cons, why am I doing that? Cons, or I guess I should have had 6, but cons 5, cons 6, cons 4, right? And this one should be, wait, what just happened to my character? Cons 4, cons 5 and cons 6, common. And this should be cons 1, cons 2, and cons 3, and common. Right, this common should definitely be the same reference as this column. I'm not sure if I do a concat, whether the common would be identical. I mean, it'll be value-wise identical, but I'm not sure it'll be reference-wise identical. But I think this will be. The common here. Once you pop this, the common will be the same. Yeah. So do the whole cracking the coding thing. At some point. Thank you. Yeah. All right. Okay. It's okay. I think that's sufficient test to sort of. And so, what should that do? Well, basically, if you pass intersection, I mean, it's a simple test. It should be it returns the common if you pass in the intersection of L1 and L2. That's what should happen. Okay, alright, well, so, boy, this is just so weird to have to do things by reference. It makes it so just weird, honestly. I guess I'm just not used to it. Alright, so, let's see. So we got the intersection, right? Function. Let's just see if I've made a mistake so far. Chapter 2, program 7, intersections. Cool. At least I don't have bad. Wait, that's not enough results, is it? How are 2 already passing? Oh, yeah. Well, I guess that's true, isn't it? Okay. Anyway. And so, how are we going to determine intersection? Well, I mean, I think with a true node-based linked list solution with mutable nodes. I guess I could mark up each node, right? And say, have you been seen yet, maybe? And if you, one list is going to hit the intersecting point before the other list, or they're literally going to hit at the same time. And so I could just walk through each list and ask the question, are the 2 nodes the same, right? If they are literally the same node, identical, then I've found the intersection point and I can return that node. But B, if I ever walk into a node that already has an intersection, or that already has the dirty bit set to true, then I know the other guy has already hit this node, which means this is the intersecting node for me, or for both of us, I should say. But if we're not going to do it that way, if we're going to do it with list, and that's actually pretty easy. I mean, I think just dirty mark the node, and of course it means you have to go clean up after yourself afterwards if you want other people to be able to use this, and you can't use it concurrently with 2 threads. But I think that's pretty simple. You just literally mark each node as being visited, and then the moment you either hit, you're walking down each linked list concurrently, and the moment you hit, this, if it could happen that you guys both hit the same node at the same time, but the moment you hit the same node, then that's one way you find the node. Or B, it's when you walk into a node that's already been marked as visited. That means somebody else already walked through this and you're done. That's the intersecting node. I think that works. But with actual list, the only way I can think to do this really for immutable list like the existing closure is to, I guess, take the count of both of them, right? And if I have the count, I know that, they would have to intersect. I know that the shorter one is the maximum intersection of the long one, or the minimum. What am I think about it? Yeah, the shorter one is the maximum intersection of the longer one, and so C1, C2. All right. So I should be able to just trim the beginning of the longer one, right? And so C larger, which is just going to be the max of C1 and C2, right? And I'm just going to, no, this sucks. I got to figure out which one is the larger one. Actually, no, I don't. I can just, it doesn't matter which one's the larger one. I'm just going to trim both of them. So 1 prime and LS2 prime, right? We're going to say map take C larger, C max. Why do I call it that? That's weird. Take C max of this guy, right? And we're going to do that for LS1 and LS2. Alright, so now we got these new lists that are equal in size, right? And okay, what do we have now? We have 2 lists that are equal in size. Can I just walk through each of them concurrently? And that should, I kind of feel like, yeah. If I walk through each of them concurrently, they should intersect at the same moment. Or they should intersect within the same, I think so. Let's just see what happens. I'm a little bit confused about that. Okay, so let's try, just putting them together basically. Combined list, right? Say, I'm just gonna take the map of the vector of list 1 prime and list 2 prime. Cool. And this combined list is gonna be, basically when the two are identical, that's the one. I guess it would be, I guess we don't really need to name this thing, right? Because we're never going to use it again. And let's see, combine vector ls1, ls2, and I'm asking filter on the ones where, or I could just say drop while, I guess, or remove, it doesn't really matter. Oh no, actually filter would be better. Alright, it doesn't really matter. Remove if, no, I'm gonna do filter. It really doesn't matter, I'm sitting here. Oh, I guess that's, remove if they're identical. Yeah, filter on the identicals, right? You want the ones where, of course, identical doesn't take a vector. Identical takes a, so apply identical the argument, right? And then, so now we should have the ones that are identical, where the nodes are identical. And we just take the first one, I think. So let's look at the rest of this. What about this? Could this guy be brought up one level? I mean, technically you could do apply this. I think that just gets too complicated. This is clear. Well, it's not actually that clear, but this isn't terribly complicated. You're taking the count of ls1 and ls2. You're then finding the max of of the two counts. Then you're saying that's not right. That's not what I meant to do. I guess you're actually saying take the, not the but last, but there's something that'll actually return the last in, I believe. Come on. It's like, yeah, drop last, I think is what we want. Returns a lazy sequence of all but the last in default 1 items in collection. So if you call drop last with no arguments, it defaults to 1, it looks like. This isn't what I want. I want to drop the first. But I only want to do it. I basically want to be left with a thing that is of minimal size. Drop last, drop while, take last. Could this be it? I've never used this. Oh, I think this is it. Yeah, so we will be paying this, like, because we're a list and not a vector. We cannot do this efficiently, right? So, but still, take last 2. That's exactly what we want, right? Cool. Take. I guess I should have looked at that. All right, so this should find. Take the last of both of them, right? So effectively, not changing one of them and trimming left trimming the other one, right? And then we're just going to convert them into vectors. We're going to, I don't like the apply, that's stupid. So let's instead, and I misspelled it. So let's instead actually just use a function and say it's a function that has an x and a y, you know, and basically asking is x identical to y. Oh, is this right? Boy, I keep doing that. Is x identical to y? And that's kind of true, but I don't think that's actually even true for... This is interesting, because, oh, I hate dealing with references and identical. It's just so lame. All right, I'm happy. I'll be happy when we get... I hopefully be on this point at some point. Or maybe I should start ignoring any question that says by reference, because it's just kind of ridiculously complicated for almost no appreciable game. But ls1, ls2, filter xy identical. That is not actually going to work the way... I mean, I think it is, right? Because it is the same value. Although our... You know, I don't actually know. So let's just comment this out. I'm just curious about things like, is 1 equal to 1? Is this identical? I'm not sure. It is actually identical. You know, those are clearly different ones, right? But I guess there's only one logical notion of 1 in the entire system. But for instance, is A equal to A? I kind of think maybe. It is, yeah. But atom is probably not equal to atom, even though they're defined identically. Yeah, okay. Ugh, this stuff is just gross. Okay, alright, so identical. I think they will actually be identical. And I guess we can only... I mean, so the thing that kind of bothers me a bit about this code right here is we're basically asking if the value in the const cell is identical, not if the const cell itself is identical, which is, like, we could do that too, right? We could just, like, loop through and basically keep
dropping, keep peeling the cons cell off, right, and taking the rest until we get to two lists that are identical, you know. Like I think we can do that, but yeah, this is. All right, could not resolve list 2, line 7. 7. LS1, LS2. Why did I call these LS's? Whatever. Lost interest in this. Not identical. 1, 2, 3, 1, 1. Well, I'll bite. I don't know where any of that's coming from. Let's start with the first one, right? That should just be like a. Oh, well, we do need to actually. I never thought about it. We actually don't want the first. We just want. Although we may want to actually map the first. So I would consider this a valid statement. You did list 1 and list 2, and you said there was no shared list. Although, yeah, actually, I wonder if that's just returning the nil list, or if that's actually saying that they do have a shared list. It's the empty list, which may be everybody's shared. It may be that this thing is used everywhere, maybe. But I would consider this a valid answer. You know, you're saying what are the intersecting points between these two things? Well, the empty list is the intersecting point. Because there really is, it's the cons onto the empty list and the empty list on. I don't know actually. Should this be nil or should this be the empty list? I don't think that's actually true. I said it, but it's not true. Actually, I don't know. I don't know whether. No, there is no. You don't have a null list. See, I'd say this is wrong. List. How about this one? List 1, 2, 3. List 1, 2, 3. Well, oddly enough, they ended up returning 1, 2, 3. And that is because, oddly enough, these integers are identical, even though they're defined in separate contexts. They're identical values. That's just super freaking confusing. I do not like this at all. How can we make it the way they want it to be, though? Okay, so if I'm going to do this, I'm literally looking at the list one at a time. I'm asking, are these two lists literally identical? Right? Oops. And if they are, they're literally the same list, then I'm going to return them. Either one, it doesn't really matter, right? But if they're not... So first of all, actually, when they're both going to become nil at the same moment, but when list 1 when there is a list 1, right? So, and if the list is identical, so if there is no list 1, it's just going to return nil, and that's expected. But if there's no list one, if there is a list one, then we're going to ask, is list one identical to list two? If it is, cool, return list one. Or list two, it doesn't really matter, right? But if they're not, then we need to recur on the rest of list one and the rest of list two. All right. I hate this code. I mean, okay. Oddly enough, we dropped one error, but what do we got now? So why is this occurring? List one and list two. This is clearly not equivalent list. All right, we got too many tests. Okay. All right, what is this guy saying? He's saying nil is not equal to the empty list. You are returning the empty list somehow. All right, well, I'll bite. Let's just print line the whole thing. All right, so the first run through, list one was equal to this, and list two is equal to that. All right. The second time through, list one was equal to the empty list, and list two is equal to the empty list. They are evidently identical in that case. That is freaking weird. Okay, so we kind of want to not say when list one, but actually then say when empty list one. Gross. All right. Okay, yeah, sure, whatever. I'm not... Is it right to say that they have an intersecting list if they have no common basis? Evidently they do. Evidently the nil list is equal to the nil list. Let's just print line this one out too. Weird. Is this equal? The empty list equal to the empty list? Yes, it is. Wow, that is... So the empty list is an equivalent list. Huh. Or an identical list. It's all the same object that is the root, which must mean... Or could it mean that the empty list is actually nil? Well, let's look at that. Is the empty list a list, or is it just the value nil? Maybe that's what's going on. Well, let's just see what we see, actually. No, it is actually the empty list, so it's a thing. Let's just check the type on it. It is, but it's a very specific thing. It's the empty list. If I put anything in there, though, now it's a persistent list as opposed to persistent list $empty list. Interesting. Okay, so that's going to cause some weird things here, right? In terms of identical checks, because yeah, it will identical on... I wonder if empty is expensive. Is it linearly expensive to do empty? It shouldn't be. It should be the moment you have something in you. The moment it can do a single first, then I guess we could sort of eyeball it, maybe. Right? So if we just look at the source. Hoi, hoi, hoi. Oh, there it is. Returns true of... Alright. Okay, so yeah, so I think they're just taking a sequence on collection, right? And then they're saying not, which I think they're nodding a nil is what they're doing. So let's just sanity check that, actually. So they're literally nodding a sequence on collection. So let's just take the sequence of it first to see what we see. Oh, I didn't mean that. Yeah, and then they're nodding that. So okay, I don't think it does have really a cost. other than running the sequence and then knotting the sequence, huh? If you couldn't return a sequence, so it depends on whether a sequence has a cost or not, a linear cost or not. I don't believe it does. I think you can take a sequence without fully linearly processing every element of the sequence. Yeah, I'm almost certain. Yeah. So okay. So anyway, not that I care about that, but well, I do, because that actually would make this algorithm n squared if sequence actually did linearly require. But right now, I think it's basically 3n, right? I mean, we have to run through this list once to find the max. We have to run through this list, the other list once to find a max. Then we are just running through it a third time. Well, then I guess we're sort of dropping a bunch of stuff. We're using the take last, which must be dropping a bunch of stuff off one of these, you know? And probably is having to take the running through them again. So I guess that's actually 1, 2, 3, 4, and then this one is a 5th run through, right? So you know, it's not a cheap algorithm, but it's big O all the same. All right, so let's see what we see. We see problems. Okay, list 1, 2, 3. List 2 is 2, 3. Oh wait, the previous one is actually from this result. So list 1 is 1, 2, 3. List 2 is 1, 2, 3. But it's based on reference. This should return it's actually returning nil, isn't it? But it shouldn't. I think I see an issue with this. I think maybe when we run the take last, I don't know if it's literally I imagine what it's doing is calling seek on it, which returns another object which can never be identical, right? In terms of the lists themselves are not identical. The values in the list are immutable and could be identical, but the lists themselves are not identical because they're being built with take last. Ugh. They're being effectively wrapped with seek with take last. Probably. I don't know if it's worth doing this problem. It's got too much stuff that cares about stuff that Clojure doesn't even deal with most of the time. I mean, we can do it by just doing it we can do it by doing the way I suggested, which is you know, make a bunch of nodes, link them together, mark them dirty as you walk through them, and you know, basically take them one at a time. If it's ever the case that the two nodes that you're looking at are both identical, then that's one way that they intersect. The other way they intersect is whenever you walk through either of the list, if you ever walk into a node that's already marked as viewed, presumably by the other one, then that's an intersecting node. That's my solution, and I'm not fixing this. Yeah. So I'm just going to leave this, and I'm not going to commit it. I am going to commit it, but I'm not going to... I got tired of working on this one. Not dealing with it as a problem. 2020 05 11, I believe. Yeah, okay. So let's move on to the last one. Loop detection. Oh no, this is a similar thing.
Okay, loop detection. Given a linked list which might contain a loop, implement an algorithm that returns the node at the beginning of the loop if one exists. This is the same. Like, there's a trivial way to do this. If you have a loop, just mark every node, or mark every node as you walk through them. If you ever walk into your own node, then or into a node that's already been viewed, then presumably you viewed it, and you should mark it, and you should note that you have a loop. You know, that's trivial. I don't want to bother programming it. It's just not that interesting, honestly. Uh, it's a lot of busy work for almost no. So what? But how would you do loop detection in an immutable line? Well, wait a minute. The answer's obvious. You wouldn't, because it's impossible to make a loop. I think with immutable data structures, right? Yeah, I think that makes sense. How can you refer to yourself if you can only refer to things that have been created, and things that have been created are immutable, right? Yeah, so it's the answer in an immutable language is with immutable data structures and only immutable data structures, you cannot create a loop, basically. Now, you can create a loop enclosure actually with atoms, right? And where basically I could create linked list where each node is an atom, and each atom is just contains a map that refers to the next and potentially also previous on a doubly linked list atoms. Um, you could do that. I would very much wonder when that's really purposeful, but you could do that. And I guess here's a purpose. Yeah, I want to detect a loop. I don't. I mean, you can't. You literally cannot create a loop with immutable data structures, right? So if you want to create a loop, you're going to have to use these weird atoms that are sort of referring to the atoms referring where the maps within the atoms are referring to other atoms, not the values within the atoms, but the atoms themselves, which is already opaque and unusual. But it does allow you to do all these things, including the ability, because you now have the ability to create a loop, right? Which you can't do with pure immutable data structures. Means that you can also check whether you have a loop, right? Um, that's interesting to think about. Yeah. So, I mean, mutable data structures allow you to create loops, and of course, now that you can create them, you can ask yourself whether they exist, right? But immutable data structures, purely speaking, do not allow loops. Um, So there's no point in writing a checker for them because they literally cannot exist. Um, okay, okay. Well, I feel bad about ending poorly, not doing 7 and 8, but I really don't like these reference questions. I really don't like these questions that force mutable stuff. But surely a link, yeah, but to 2.8's point, surely I mean, you must I think I may think about coming back to these much later. They're just not, I think, interesting to work upon. But much later, when I think I may just write a small function to convert. Because like when somebody says by reference, what they really mean is, well, they really mean using the fact that I can refer to something by reference means I know it can only exist at one location, and its memory address is also effectively its identifier. Um, but we can give things unique identifiers. That's not a now. The weird thing about functional immutable languages is it doesn't really matter whether it's a value or a copy, or it's a copy or the same value. It doesn't really matter. I think 99% of the time that's a very good characteristic. But like if you did have a notion of a map, um,
or sorry, a notion of a, I'm getting tired. If you did have a graph that did have loops within it, how can you represent that with an immutable data structure? That is something I'll have to do some research on. I actually don't know how people do that. You know, the only thing I can think to do is you pretty much have to have a thing that can be amended, which means at minimum it has to be an atom referring to other with whose value within it refers to other atoms. Right. That's the only way I can think that you could do that. Yeah, but I'll try to look it up some. Anyway, I'm just gonna move forward, and I'm gonna save this whole commit as a sort of like weird commit. Because it's just me rambling mostly. Failure to complete 2.7 and 2.8. In interview. Let's start writing it this way. All right. So yeah, once I commit this, I'm tired. Honestly, it's getting late. Yeah. So yeah, it's disappointing. I don't care about the 2.7 thing, the intersection thing. I mean, this is just that one isn't a big deal, right? We could convert our list of our reference link list into convert every node into something that we can put into a normal closure link list, and we could add a GUID to it to make sure that we are talking about the same item here. You know, although realistically, yes, the item can be copied. It doesn't really matter whether it's the same or it's a copy of the original. It makes no difference. But on the presumption that we were the ones who gave it the GUID, that we won't be copying it, then we can just deal with that. That's not a huge thing. The 2.8 thing, how do you deal with graph data structures where, or with data structures that have loops in them? You know, it's never something I've done with the functional language, so I'm not entirely sure. I mean, the only thing that comes to mind is, like I said, atoms that refer to that have values that refer to other atoms. You know, atoms that have values within them that refer to other atoms. It's the only way I could think to do a loop in Clojure. But unless, oh, you know, I just thought of something. No, I got a different idea. Well, we'll talk about that some other time. Yeah, but yeah, I think I could indirectly reference a loop by I could create a quote loop using purely immutable data structures using something like a like if I use the actual value at that of the node as, you know, if I give each node an index position, then I can make a sort of a list of um, where for each index, tell me what things this thing points to, you know, right? And or that tell me, yeah, for each index, tell me what items is in. So it'd be a map, right? They contain. Let's say your graph contained 5 items, right? So 5 different keys. I'm going to give them keys 0 through 4, right? I'm giving them the keys, so that's under my control, and nobody's messing with that, you know. So 0 through 4, and then I'm saying like 0. Let's just say it's actually just a linked list. The graph is right. 0 points to 1, 1 points to 2, 2 points to 3, 3 points to 4, right? You just have another map that contains keys, right? And each of them would contain a set where, you know, the key at 0 would point to the set containing 1. The key at 1 would point to the set containing 2. The key at, and so right now we just have the normal link. We have a linked list in just a completely different way, right? Represented in a completely different way. But then what we can also do is we can say, hey, I want to link 4, index element 4, the fifth item in the collection. I want to link it, quote unquote, to back to 0, right? I want to make a loop out of my list. And you can do that by just creating a new data structure. By just going to that connection lookup thing, going to key 4, and rather than just previously key 4 pointed to nothing, right? It was the empty set, but just point key 4 to or add 0 to key 4, right? Set to add 0 to key 4 set. Now that's a loop, right? You turned a linked list into a loop. And yeah, with that data structure, you should be, I guess you could, yeah, you should be able to do any type of loop. But the only way is, yeah, and what is the property that makes that true? The property that makes it true is you're not directly talking about the value. You're not directly pointing to the value. You're indirectly pointing to the index position of the value. That's why you can do it. Okay, so actually, that's interesting. So you could definitely do the loop detection with that, right? I mean, you could just be, starting at some value, walk through the entire thing. I mean, you can do whatever you want. It's your immutable data structure, right? You can just be adding in a key, just like I said with the other guys. You could be adding in a key to every map that says like visited, right? If you ever run into one that's visited, then you're done. That's actually a pretty cool thing. And for the intersection, I feel like you can. I'd have to think about it. I really don't like 2.7. Actually, I think I'm okay with 2.8. I was more concerned about 2.8 because I'm like, that's really frightening if there's something that just cannot be done with an immutable data structure, right? But it's not. It's just you got to represent it in a slightly different way. Rather than having nodes directly referring to other nodes, you need to have another data structure that says like this node at this index position is able to reach these other nodes, right? And with that, you can do anything, I think, in the same way. Um, 2.7, it's really the whole is defined based on reference, not value, that makes it confusing. Um, it's not confusing. It's just like what it. Well, no, it's just overly difficult in a functional language to be dealing with things by reference. Or maybe it's just because like none of the maybe it's because I'm just not familiar with doing it that way. But maybe it's also and I do know how we could do it. Like I said, a link list of atoms, right? We could do it that way. It's just that seems like such a weird thing to do in a language like this. You have a list data structure. Why the hell do you have to define this weird link list thing as a sequence of nodes that you're manipulating? That seems very strange to me. I would much rather use the native built-in list. Um, Interesting. Okay. Yes, I would probably say if I'm going to redo 2.7, I will simply say, look, I know it says by reference, but I'm doing it by value for multiple reasons. The biggest one being that anything that you're talking about that should be by reference, I can just add a GUID to it, and effectively I can do it by value. Even though and now if I add the GUID and I'm the one who controls the GUID, I know nobody else has I know value equality by GUID is equivalent to reference equality uh, given by the system. So all right, yeah, I'm gonna skip these two because I've rambled about them enough, but it's been interesting to think about, and I've realized some blind spots in my thinking. So that's actually, I guess ultimately they're kind of good questions actually, despite all my belly aching about them. Anyway, yeah, tomorrow I'll be doing what's next? Stacks and queues. Yeah, stacks and queues. Probably be doing it in the morning. So anyway, uh,